If you've been building CRUD applications with a traditional layered architecture, then you might make things harder than they need to be. And in this video, I will show you how to build a simple but scalable CRUD app with a vertical slice architecture and a .NET Web API. And the best part, you can download the complete source code for free by using the link in the video description below. So let's dive right in after hitting that like button. All right, so we're going to build a .NET Web API, so ASP.NET Core Web API it is in Visual Studio, and I call this thing Video Game API VSA for Vertical Slice Architecture, and I want to build a video game API just for this simple example. We hit next. I'm choosing .NET 9. It's the latest version, no authentication. And yes, we are going to use controllers in this example. So let's check this checkbox here, or select this checkbox. We hit create, and there we are. And the Solution Explorer is the very first thing that we should have a look at, because what do we need here? Well, the very first thing, boilerplate, is pretty similar to any other .NET Web API or application you would want to build. In this case, we need an entity, and then I also want to use EF Core or Entity Framework with a SQL Server database, SQL Server Express. So let's add another folder here and call this thing, if Visual Studio lets me, simply entities, like that. And then we create our new item and call this a video game, because this is in the end what we want to implement in this example. Now, I installed GitHub Copilot lately because it is free now, but and this is why we get the suggestion here, but let's try to use it or implement it manually a little bit. So ID integer, I know we could also use a GUID, but let's keep things simple, or as simple as possible. So only an ID, then let's say we have a title and already initialize this thing as an empty string. Then another thing I would like, yeah, that's true, a genre, similar result. And then the last thing is as an integer, the release year. All right, let's do it like that. And now already the next step would be our database context. So first, a new folder. You can call this data, you can call this infrastructure, whatever you like. And then for the boilerplate stuff, check out the chapters if you already know all that. Entity framework stuff, then you can skip this, of course. But now let's enter the video game DB context. And now I'm curious if something was there already. So DB context, right? And for that we need entity framework core. So install this thing. We add the using, and now here Copilot says video game DB. Yep, this looks actually pretty nice, but we don't need this, and we need the using directive here. I mean, why not? We have the video game DB context defined here with the options, the mandatory options. Use the base constructor here as well. And then as a database set, we got our video games. So this then will be our table in the end. But now we have to register this thing as well. So we go to the program CS, and here now we write builder services, and then add DB context, video game DB context with options using the SQL Server, that's correct, and the connection string, and we can use the default connection here, like that. And of course the using directive, or the reference for the video game, almost not the context, it's the DB context. So now we can add this reference here, and we need the package for the SQL Server provider, and also of course the default connection, the connection string, usually in our app settings JSON file. But first let's add some packages. So right click your project, manage NuGet packages, and here now first thing SQL server it is. This one here, Microsoft SQL Server Database Provider for Entity Framework Core. So install that. We hit accept. Perfect. And then we can already install something else. And these would be the tools, Entity Framework Core tools. And as you can see here, we get a bunch of options here like add migration, bundle migration, update database, and so on. So let's install that as well, because I want to use code first migrations in this little tutorial here. So let's save everything, and we add the using directive, the reference to Entity Framework Core. That's it. And now the connection string. So here now we add, yes, this is what I want to add, connection strings, default connection, but the connection string looks a bit different. So that would be now, in my case, a localhost // and then SQL Express. The database is the video game DB, why not? Trusted connection true. And here, instead of the multiple active results set, I would like to add trust server certificate, because this is necessary. All right, I think this should be it. Okay, so let's try to add the migration with add dash migration initial, and we get, hopefully, yep, a migration file. So there it is, and you can find it under migrations, and then the initial migration, and we, or Entity Framework, would create a table with a dtitle, genre, and release year, and a primary key. So let's do exactly that. So package manager console, and now update database, and Entity Framework will do its magic. And as you can see, it already created the table here and before the database if it doesn't exist. So now let's go to Microsoft. There it is, SQL Server Management Studio, and we refresh the databases. And what do we have here? Okay, Blazing Block Time Tracker is from the .NET Web Academy. Maybe you want to check the Academy out if you really want to level up your .NET and Blazor skills. Dive deeper with the fam and me in the .NET Web Academy. It's cringe, I know. And yeah, then we got the CRM database from the live streams. Maybe you want to check out the live streams as well. But this is the one that is interesting for us now, the video game database with only one table that we use. EF Migrations History is used internally by Entity Framework for all the migration stuff. But here now the video games database, great. There it is, but we have no data so far. But this is what we now want to do with code, or maybe we will add one manually and get this one first. So now comes actually the vertical slice architecture. And if you haven't watched my other video about the vertical slice architecture, comparing it with clean architecture, don't get me wrong, clean architecture is amazing. Still, I love it. You have layers there, you have structure there, low coupling or loose coupling rather, but it's most of the time rather suited for bigger applications, right? Really big things that you want to build. But if you want to build something rather small and it maybe only scales to a, let's say, mid-size application and not a really large application, then you can totally work with vertical slice architecture. Because with that, you also have really loose coupling, but also a high cohesion, which means that everything that needs to be set together for a certain feature is close together. It's not spread over layers, over projects, you name it, but it usually is set into only one little folder or even one little file. And this is what we're going to do now. So I already said features. You organize everything around features or use cases with the vertical slice architecture. So this means that here now we create a new folder, call it features, almost features. All right, and then what we can do is create another folder for the, let's say, actual topic or the entity. In our case, this would be video games. And now when I say I want to get all video games, right? Or get a single video game, whatever it is. You can either create a folder for that or just a file. In our case, it's a really small example, so you can do everything with one single file, all right? So let's do that now. We create a new item and call this now GetAllGames, okay? Now here, the thing is, we will already work with CQRS, or you could also say the Reaper pattern. So CQRS, command query responsibility segregation, and then also Reaper request endpoint response. So this means first, I have to explain that. I try to explain it really quick. Command query responsibility segregation just means, you know, that you have a web service, a .NET Web API, you have a request, and with CQRS, you split these requests, let's say, into queries and in commands. The biggest reason for that is that with queries, you only get select statements in your database after all. You only read data, you cannot change or even destroy data. This is what a command can do. With commands, you want to update the database or entries, their rows there in the database table. You want to add new rows, and you maybe also want to delete something. So you actually change the database, and this is why it's called a command. Query only getting data, reading data, all right? So cannot destroy anything. So this is CQRS in a nutshell, but we will implement it, use it, and then you see what else is used when using this pattern. And regarding the Reaper pattern, response, endpoint, request, somehow you can use them together, or you can also say that you just want to use the request endpoint response pattern. This means in essence that your application is, or your web API is built really lean. In this file now, we will have a request object or a request class, or maybe a record. Then we will also have a handler for all the logic, and then also a response, and then also an endpoint. So as I said, they can work together, but let's just implement it, and I think then you will get what I mean. There's only one thing that I want to add before we do it, and this is adding the MediatR package. I can already read the comments in my mind because you asked that before. Why adding MediatR here? It doesn't make sense. Well, let me just show you why I am going to add it. Here is the MediatR package by Jimmy Bogart. Jimmy Bogart, by the way, also the guy who, let's say, invented the name or the term vertical slice architecture. So amazing guy. And now here, what I want to do is, I already told you about CQRS and the request object. So the first thing is actually turning this into a static class, like that, and then we nest some classes here. So first thing is a record actually, and this is just our query. The nice thing now about using the static class is that we can just call this query. We don't have to call this GetAllGames query, just call it query. And if you want to reference to this thing, use a UI Blazor, for instance, and then use this query there, then you can say, okay, create a new GetAllGames.query. All right, and now here GitHub Copilot already suggests the correct thing. We want to implement the iRequest interface from MediatR. And what is this thing doing? Well, give me just a sec after adding the references here. Now here it says a marker interface to represent a request with a response. So this means in the end, MediatR also gives you structure. Again, it is not necessary to use MediatR at all. You can do everything in this one single class, use it together with your endpoints or your controllers without MediatR, even without CQRS. You can just call these things requests, then you do something with this request in a handle method, for instance, and then return a response and add your endpoint there. But in my opinion, well, I'm not that experienced with vertical slice architecture. It's pretty new to me as well, but I think it gives you structure, all right? And this is what I like about using MediatR in this specific case. All right, we got our requests. Now we also need a response object. Yes, Copilot, we also need a handler, but let's start with the response object, please. So we again add a record, which is our response. and we want to return the ID, a title, and the release here. This is correct. Now we need the handler. This is what Copilot suggests. We see the handler, which is a class implementing the iRequest handler, which comes from the MediatR package, with our query return and then returning the IEnumerable response. So far, so good. Then we need a DB context, which we could use also with the, or as a primary constructor there. So maybe we change that. And then we have a method down here, an asynchronous method returning the response list, let's say. That's correct. With a handle method, we get a query request and it returns all video games and then maps them here manually. So let's just use this. But again, what I would like to do or to use is the primary constructor here. So video game DB context it is. I call this context here, so we don't need this code. And here we can just call or use the context, and here we need entity framework again as a reference, like that. And here it says there's something up with the types, and this is actually correct because we want to return the response. And here's the same thing, because it says us or tells us here we need to add our response object here, right? See, it gives you structure, it makes you think. And I actually indeed don't want to return the entity class, the video game. I want to return the response, and now the error is gone. So we got our logic here so far, right? We have a query, we have a response, we have the handler with the handle method, which you have to implement when you're implementing the iRequest handler interface here. But one thing is missing, and this is our endpoint. And in this tutorial, I want to use traditional controllers. In another tutorial, I will use minimal API endpoints, but here now, controllers. So let's just add one controller here real quick. API controller it is. And we add the reference here. We give this thing a route. This looks good to me. Or let's just use games here, like that. And now regarding the logic, Copilot is already suggesting something. So yes, this should be a video games controller, but actually rather a GetAllGames controller. So we have to fix that. Again, we can use a primary constructor. It's funny, like how the tutorials change when I use Copilot, because we see a suggestion, analyze it, and then change the code. So this is working with AI now, I guess. Anyways, then we get have the HTTP GET method, which is correct, but also here I would like to change something. You know what? Let's just implement it manually. So public class get games or GetAllGames controller with the iSender. Why not iMediator? Because we do not need events. iMediator also provides events, but this is not what I need here now. Okay, and now our HTTP GET methods with public async task action result actually IEnumerable. Now let's see, GetAllGames response. All right, we could also remove this and just use the response like that and just add the reference here. So this is totally up to you. We call this GetAllGames as well. And then we return actually var response await sender send new GetAllGames query. So this is the query. We give the mediator, and the mediator we send it to the mediator, let's say, and the mediator knows what to do. So it's not like traditional services where you call a specific service and then the service has to maybe call a repository or do its DB context magic then there. We just have this centralized mediator thingy object there. So we can say, as a controller, just send this type of query to the mediator. The mediator knows what to do with that thing, and then it will return the proper response. All right, but before we can test this now, we have to add Scalar. So again, Solution Explorer it is, and we managed the NuGet packages. And this time it is Scalar because we don't have Swagger anymore out of the box with our since.NET 9. So now the new cool kid on the block is Scalar, although you could also use Swagger still. If you want, you can also install Swagger UI for your .NET Web API. But here you see generate beautiful interactive API documentation from Open API Swagger documents. So let's install this thing. And then we have to add something in the program CS. You already see here now add Open API, this is new since .NET 9, adds Open API services related to the default document to the specified iService collection. And now to be able to use this Open API reference, we now use or add app map, that's the one, map Scalar API reference, like that. It will add the reference here as well. And as you can see, it says now maps the Scalar API reference endpoint with the default endpoint prefix /Scalar redirects to the trading from Scalar to Scalar. All right, this ensures that the blah, 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 this method overload is compatible with the obsolete Scalar options. Okay. What this does is that we get a beautiful UI where we can test our API. And just so you know, add Open API here, you could also add another string here for the version of the current API, for instance, the so-called document name. And by default, it's v1 for version 1. And this is what we are going to use in our little test here. Now we can run this, but by default now, browser won't open by default. So you see it here, launch browser is set to false. So this is why we have to manually open up this URL. There it is. Now there's not a lot to see, right? But we have to enter Scalar and then the just mentioned version 1. And there's our endpoint now, the GetAllGames controller. This is now definitely one disadvantage. We have or will have a couple of controllers now, a few controllers when we do it that way. But there's also a minimal API way, so you can decide yourself what's better for you. Also, weather forecast and models are there. This is not interesting for us. But here, anyways, we got GetAllGames. This is the controller, and the API is API games. This is a get call. When we test this, of course, we get no games, and we also forgot one thing. Awesome. So we have to register MediatR as well. So let's do that real quick. Sorry about that. So real quick in the program CS, now maybe down here, yeah, let's say builder services add MediatR, and we have to configure this a little bit. So config is now config register almost register services from assembly, and our assembly we just use program assembly like that. All right, and here now you see registers handlers and mediator types from the specified assemblies. Now everything works. Restart the app. There it is. We just reload manually. Test request. And now it works, but we get no game. All right, so let's just add a game for testing purposes real quick. So I'm currently playing Spider-Man. It is, let's say, an action adventure, and it came or was released 2018. All right, so let's make this bigger. Okay. And when I now hit send, we get Spider-Man with the ID 1. The Action Adventure 2018. Isn't that nice? All right, and this is how you implement the very first get call to GetAllGames. And now comes the fun part, really, right? What about all the other CRUD operations? Well, let's just do that one after another. The very next one I want to implement is creating a game, so we don't have to add data manually in the database. So we add a new file again, call this create game. And again, this is then a static class. And since we now changed something in the database, we won't use a query. This time we will use a command. And Copilot again suggests something here. let's see, we got a record with a command that's true with a string title, a genre, and a release year. This is correct. And an I request response is what we want to return. Now the response is also a record again with the ID, string, title, and the release year. Maybe we just return the game that we just created. Why not? Then, oh, it already learned. It uses now the primary constructor as well. We have the handler class with the video game DB context, taking a command, returning a response, and then the logic says we have our async task method handle. We'll create a new video game. It adds it to the database, save changes async, and returns the new response. Okay, actually, I think this is correct. We just add the references. And here's our video game reference. All right. Well, why not? Let's just try it. Maybe add some space here. And yeah, then only the endpoint is left, actually. Maybe I missed something. Well, let's just try it. So this is create game, all the logic, but now the endpoint. Yes, API controller it is. What does Copilot say? We add the reference. Now here we have the route API games. This is also fine. And now Copilot says public class create game controller, user inheriting from controller base. And again, we have the sender there, but again, I would like to use at least the primary constructor. So I sender it is. So we save some lines here. It is a response and command, and we use this sender here. So again, as you can see, now we don't have to use any kind of service or anything. Now, if you don't want to use MediatR in this specific example, you could use directly the handler class here, for instance, and then the handle method instead of using MediatR here with the sender object. All right. So this is what you can do instead. But I think so far this looks pretty good to me. So let's just try that, shall we? Restarting the application, closing this thingy here, and where's the browser? There it is, we reload. We have now our create game controller with this test request. Already suggested here is title, genre, and release year. Well, let's add something else. So, for instance, pretty simple Skyrim, a role-playing game released 2011. We hit send, and we get the object back. Now we can change that, of course. So instead of returning the actual response, typically when you use this create endpoint, you could also use created, right? With now the actual route, which would be API games, and then the response ID, and then we can add the response here like that. And then if you would have an endpoint just to get a single game, this would be the result that you could work with. So then you get the actual URL or the route for this single game. When we try that again, test requests, let's say Cyberpunk 2077, and well, it's actually also an RPG, not really a shooter, right? So here now it came out 2020. So now we return the created status code to 01, and here in the headers you see the actual location, right? We could use this now if we would have implemented the get by ID or something like that, endpoint to get a single game, and so on. I think you get the idea. Now let's try something else, and that would be updating. This would be the next step, I guess. Let's add another file. Add a new item. Update game it is. Again, a static class, and is Copilot suggesting something if we wait long enough? Yeah, it does. This is crazy. So now we get a record with command int ID, title, genre, release year, and we return a response again, the resulting objects. And again, we got a handler, and in the handler, we first try to get the actual video game that we want to change. Okay. And then we change title, genre, release year. We save the changes and return the response. Okay, let's double check and add the references again. So here now, MediatR video game DB context, it is. And we have the response context video game. This is correct, not found exception. Yeah, or return null, whatever you like. Now regarding this exception, we don't have that kind of exception, so we could just throw an exception or return null. Let's say we throw throw an exception with a video game with given ID not found. We change title, genre, and so on, save the changes here, and return the actual changed data of the video game. And now again comes the controller. All right, API controller it is. We have the route, we add the reference. What about the controller? It's the update game controller. Now it is learning. This is crazy, right? Now it is using the sender in the primary constructor, or adding the sender there. Yes, HTTP put with the ID. This is correct. Let me just use this. This is fine for me. And it's the put method now, right, for updating. So then we have the ID here as a route. We grab the response, update game with the command here. This is also nice, ID in the route and body do not match. So we really make sure this way that the command object that we send has the same ID as the one we want to use in the route. Little validation here, let's say. Then we got the response with await sender sent, and yeah, we're throwing an exception. What else we could do is, instead of throwing the exception, we could return null and then check if the response is null, then we return a not found. So let me try that maybe. So here now we just return null like that. But to make this work, we add the question mark here and also here and here. So a nullable response in the end that we are able to return. And here now we can just check if the response is null. We return not found. This is totally correct, Copilot. Okay, this is crazy. I like that. I really like that. And this was not prepared. I did not know that Copilot would work that well and learns so fast. So now we have our update. Let's try that. We restart the app. There we are. Go to update. Let's go to update, send or test request. We have to set an ID there. So let's say 2, and here for testing purposes the 1. Then we got Skyrim. Almost. Jesus. Today is not my writing day. Skyrim. Now let's just change that to role-playing game. 2011 it is. We hit send and it says bad request, ID in the route and body do not match. This is absolutely true. So now we wait. Let's double check in the database. So here now execute. Yeah, ID2 is Skyrim. All right. So now let's send this and we get a 200. Okay. ID2 Skyrim role playing game 2011, and in the database it also says role-playing game now. Great. So only deleting is left. So let's implement that real quick. Again, Solution Explorer. We add another class, a new item. Call this now delete game. Don't forget you can download the complete source code for free. A link in the video description below. So now this is our delete game class, and I think Copilot has an idea now. All right, with int ID request response. Well, actually this changes now, because what I want to do here is simply return a true or false, so a Boolean value. So we actually don't need a response object. So maybe this time we just write it ourselves, public record command with and then and an ID. This is correct. Now I applied everything. Okay, but regarding the return type, it's just bool. We add the reference here and here. So no response in this case. And here we just add bool. So we have a response, but not a response object, let's say. So now bool, it is like that. We try to get the video game first. This is correct. If the video game is null, then we return false. And here we say context video games, remove video game. This is also correct. We save the changes. And now here we simply return true, like that. And the last endpoint now, API controller it is. All right, add the reference already. And now regarding the endpoint, we get a new controller, I guess. Copilot, right? Give it to me. What's that? Namespace cannot directly. What did I do? Okay, then we just add it manually. So yeah, there it is. Delete game controller. All right, inheriting from controller base. We have the ID with the delete request method, now HTTP request method. Action result bool, delete game. We send our command. If, yeah, this is false, we get not found, video game with given ID not found. And otherwise, it, well, it can actually just return no content, like that. Let's try it. Okay. It's really funny that this tutorial has so much to do with AI now. I swear this was not planned. But anyways, interesting. Please tell me in the comments what you think if you're still here. Thank you so much. But what do you think about all this working with Copilot now? Because the suggestions are pretty interesting in my opinion. But anyways, let's just reload the app. Here's delete. We test the requests. Let's say we try to delete something that is not there. We get video game with given ID not found. Great. And what if you want to delete Cyberpunk now? No content. But if we try to get all games, we hit test request, send, there they are. And in the database now, we see it's gone as well. Great. But what about minimal APIs now? You saw that in the controller, let me open it up again, or in our files now, we have this big controller stuff that we're doing, and maybe it's also not that great when we again have a look at the browser and the UI. Well, it depends if you are actually using this, but we have a single controller for every endpoint, right? And maybe this is not the best way. Maybe there's a better way using minimal APIs, but with minimal APIs, then the program CS can get bloated, right? Well, there is a really nice way to use minimal APIs with vertical slice architecture. And if you want to know what this way is, check out this video here on the screen.